To prove this relation, consider the generating function of Legendre polynomial. The generating function of Legendre polynomial is 1 minus 2 xz plus z square or minus half, which is equal to z power n into n of x, where n equal to 0 to infinity. This is equation 1. Now, differentiate this equation 1 with respect to z. We can get minus 1 by 2 1 minus 2 xz plus z square or minus 3 by 2. Then if we differentiate this function, we can get minus 2x plus 2z. On the right hand side, we can write n into z power n minus 1 into Pn of x. Then take this minus 2 outside. This term is changed as minus 2 into x minus z. Then minus 2 into minus 1 by 2 is plus 1. So this is modified as x minus z into 1 minus 2 xz plus z square or minus 3 by 2. Our right hand side is n into z power n minus 1 into Pn of x. Say this is equation 2. Now, multiply both sides of equation 2 by 1 minus 2 xz plus z square power 1. Then x minus z 1 minus 2 xz plus z square into 1 minus 2 xz plus z square or minus 3 by 2, which is equal to n z power n minus 1 1 minus 2 xz plus z square into Pn of x. You have to apply a power m into a power n. That rule, a power m into a power n equal to a power m plus n. If I add the powers, we can get x minus z 1 minus 2 xz plus z square power minus 1 by 2, which is equal to n z power n minus 1 1 minus 2 xz plus z square into Pn of x. You know the value of 1 minus 2 xz plus z square power minus 1 by 2, which is our generating function, z power n into Pn of x. Therefore, this is modified as x minus z into z power n into Pn of x. This is equal to n into z power n minus 1 Pn of x minus 2 ns z power n plus n into z power n plus 1 into Pn of x. Just I have multiplied all the terms by n z power n minus 1. Here we have to add one Pn of x minus 2 nx z power n into Pn of x. So that consider this is equation 3. This is further modified as x z power n minus z power n plus 1. See, x z power n into Pn of x, x z power n into Pn of x minus z power n plus 1 into Pn of x. Here n z power n minus 1 Pn of x minus 2nx z power n Pn of x plus n into z power n plus 1 Pn of x. This is equation 4. Now we have to express all the powers of z in terms of n minus 1. For that, we should provide some modification to equation 4. Consider the equation 4 and try to present all the terms of z in terms of z power n minus 1. Here z power n is present, we have to replace n by means of n minus 1. So the first term of equation 4 takes the form x into z power n minus 1, then p n minus 1 of x, replace n by means of n minus 1. Here z power n plus 1 is present, we have to express in terms of z power n minus 1. So this n should be replaced by n minus 2. Z power, if you replace n by means of n minus 2, n minus 2 plus 1, n minus 1. P suffix n minus 2 to x. Here the first term is expressed in terms of z power n minus 1. So n is present as such. N into z power n minus 1 Pn of x. Here z power n is present. We need in terms of z power n minus 1. So replace n by means of n minus 1. 2 into n minus 1 x z power n minus 1 Pn minus 1 of x. Here z power n plus 2 is present, so replace n by means of n minus 2 plus n minus 2 z power n minus 1 p n minus 2 of x. So this is equation 5. Now we have to equate the coefficient of z power n minus 1 on equating the coefficient of z power n minus 1, we get, see that z power n minus 1, we have to equate the coefficient. The first term is x Pn minus 1 of x, x into Pn1 p suffix n minus 1 of x minus Pn minus 2 of x, then n into Pn of x minus 2n minus 1 x into Pn1 p suffix n minus 1 of x plus n minus 2 Pn minus 2 of x. Now keep this term n Pn of x left hand side, n into Pn of x, then bring all the terms to one direction, x Pn minus 1 of x, then bring this term plus 2 n minus 1 x into Pn minus 1 of x, then write down this term as such, minus Pn minus 2 of x, and shift this term to this side, minus n minus 2 Pn minus 2 of x. Without this, all of the terms are brought to the left hand side. So x Pn minus 1 of x, then bring this term to the left hand side, plus 2n minus 1 x Pn minus x, then minus Pn minus 2 of x. If we shift this term to the left hand side, minus n minus 2 into Pn minus 2 of x. Then this is equal to, take this x Pn minus 1 of x as a common term. We have to write 2n minus 2 plus 1. Just we have combined these two terms. X into Pn minus 1 of x is taken out. This is 2n minus 2 plus 1. Then take this minus Pn minus 2 of x outside. This is n minus 2 minus Pn minus 2 of x is taken out. So n minus 2 is present here, plus 1. This is equal to x Pn minus 1 of x into 2n minus 2 plus 1, that is 2n minus 1 minus Pn minus 2 of x into n minus 2 plus 1, n minus 1. Left hand side is n Pn of x. Now we have arrived at the result. See that nPn of x equal to 2n minus 1 into x Pn minus 1 of x. 2n minus 1 x Pn minus 1 of x minus n minus 1 into Pn minus 2 of x. Pn minus 2 of x into n minus 1. That's all about the proof.